I am going to talk about a power plant. Now I am going to give a PowerPoint presentation. Okay. So initially what we did, we have done 3D rendered image we have submitted to the client. So this was the rendered image, and that is the outcome, what we have done. So we are able to achieve near whatever we dreamt, that has been come out. This project, that's a Hyderabad Integrated Municipal Solid Waste, 20 megawatt power plant at Jawahar Nagar, Hyderabad. So this, now every day in our country, a lot of waste is being produced. And with this project, we are able to convert per day 1200 tons of waste, and we have converted into energy. This is the capacity of the plant is 20 megawatt. This is the first WTE plant in South India. The first plant was in Delhi. The raw material is simple. It's a household waste, and that they are going to, GHMC is going to carry to the dump yard, and it will be dumped at one place. The overall cost of the project is 500 crores, including civil and steel structures, with equipment, of course. They have started civil works in July 2019. There are some milestones in the project, very interesting milestones. Steel structure start date is February 2020. Of course, everybody got a problem with the COVID. So even this project also, it got stalled for some time. Then, in spite of that, they have completed in November 2020. That means in one calendar year, they could able to complete. Karthikeya Industry, they have done a wonderful job. We have to appreciate their effort in completing the job, in spite of all the problems we faced due to COVID. The total area of the premises is 120 acres. The size of the building is 148.5 by 72.2 meters. The total tonnage is 220 metric tons. 2,200. This is the total layout. It's a bird's eye view of the total site layout. There, if you look at this portion of it is a dump yard, and it will be transported into the tipping hall. This is the tipping hall. And it will be dumped into the MSW pit. From MSW pit, it will be collected. And this tall structure, is a 55 meters height. There it will be, a boiler will be placed. It will be burnt in the boiler. Thereby, we are going to produce the power. The general layout, if you look at it, the initial stage is tipping hall. MSW pit, that is a minus 5.5 meters from the ground level. And the pit depth is, above ground it is 40 meters. The total pit depth is 45 meters. And the next comes a boiler shed and back filter and finished goods area. So if we start with the back filter shed, so the size of the back filter shed is 41.5 meters by 65.82. The height of the structure is 22 meters. This span is 64 meters. We have taken a ridge line here. Can I get the props, please? You come this side. This is 64 meters. So challenge is to design a structure with a 64 meters is quite challenging. but they don't want a more number of columns inside the building because that will hamper their activity. So that's the reason we have taken only one column in between, only one column, and at the center, exactly at the center we have taken, and we have taken a jog beam. On that jog beam, we have supported all these trusses. So jog beam is running through and through. So just imagine a jog beam, okay? You can keep it. You can keep it this side. So challenge would be like, installing 64 meters is really difficult. We made 32 meters. So 32 meters erection is quite easy, and it is, we are able to achieve the desired results with that. This is the cross section. If you look at it, we have taken a single column. On that column, we have taken a jog beam. Jog beam is running all through. So this is, other than column area, this is the cross section. Normally, the erection of rafter below 30 meters is quite easy, but it is more than 30 meters, 64 meters, we have divided into 32, 32. So that is the reason, and also it becomes, the challenge would be when we are keeping this 64 meters, longitudinally maybe it is okay, but laterally it will be, you can see this, laterally it is weak, longitudinally it is strong. So we have to see that if it is a span is such that if it is more than 30 meters, we should try and do a less than 30 meters. It is easy. Of course, we have done 68 meter column free space structures also. And next thing is a boiler shed. Boiler shed is a 46 meters by 65 meters by 53.65 meters. There the challenge has, they don't want a column again for the process requirement. What the gable end, what we did, we have taken one more single column. On that, a girder has been taken. That's a box girder we have taken. We have taken the floating columns on that. And don't think that the entire load will be carried by only the box girder. As a frame, it is acting like. It's not a single member, it is taking the load. We have analyzed the construction sequence also. So we have supported the system also from the bottom so that we could able to achieve the total frame is coming into the action. There, that is a gable end. So after this, we have taken a runners also. So in the MSW pit, we have the columns, RCC columns, we have taken up to 40 meters height. Above, we have taken this is a one-side slope structure. So nearly 10 meters on the lower side, and it is matching with the requirement, the other side. The tipping hall is 30 meters by 72 meters. The 16 meters is the height from the ground. There, one more challenge we got. The client wanted a elevation which looks like a box. They don't want to look like a shed. So the challenge is we had to go with a nearly 4.5 to 5 meters. This side, we have to erect a member so that it looks a one box to camouflage the ridge line. So for that reason, what we have done, okay, come. this is the arrangement what we have done. This is near about 4.5 to 5 meters. So normally people might think, what is the big deal in that? So if you take only one support from here, let's say, sorry, so it will end up in a lot of moment on this. We have taken two supports so that we are able to convert this force into the moment due to this wind force, convert into the forces. So when there is a wind on this side, so when there is a wind on this side, so this will be, this member is going to be in the compression, this member is going to be the tension. If it is the other way around, then this member is going to be in a tension, this member is going to be in a compression. So that is how we could able to achieve the required result optimally. So that is the section I am trying to tell you. And the wind bracings, we have taken the wind bracings wherever it is necessary. So I will show you another slides also how we have taken the wind bracings. And these 55 meters height columns we have taken. The boiler shed, one direction it is not supported, only at the 55 meters it is supported. So 55 meters, that means we cannot give you, such a big column. This is a column size is 1800 by 1200. 1800 by 1200, and as we go up, it got reduced. But the challenge is, in the STAD, we can give you only single member property for the analysis. What happens now? We require to give a rational thinking for that. So what we did, for a tie beams also, we have made a lattice like this. So we have made a lattice. For the columns also, what we did, inside also, we have provided all angles, and inside this, and people used to walk inside the column, and they have made, we have created one more angular member so that there will not be any web buckling of this member, so that otherwise web buckling will be very high, so for such a kind of a big box columns. So with that, we are able to achieve the web buckling problem. And also the tie beams, these members we have introduced before delivering it to the site. How we introduced? At every 4.5 meters, this is the scenario. So you can see all these tie beams introduced within the column also and externally also. So this is, with that we are able to achieve the required result. Why? Because if there is no interconnected members inside the column, the web may buckle. So that is the reason we have thoughtfully what we have made, the members we have introduced inside also, so that it exactly matched the outside tie beam also. So this is the general cross section, if you look at it. So gable end. This is a roof plan. So all the roof we have taken all the wind bracing all around, because it's a very tall structure, and in this direction only at 55 meters it is got connected in the boiler shed. No connection in between. It's only horizontally we have taken the tie beams. This is the STAD model. Now coming back to the basics. The basic wind speed 44 meters per second in Hyderabad. Roof live load we have taken 75 kg per square meter. The allowable sway is 230 mm, but we have limited only 155 mm. So if we allow more sway, there is a chance of breaking, of sheeting over a period of time. That is the reason we have allowed only 155 mm. So this is not, I mean, making a member, a passing a member is not a difficult task. Here, such a tall structure, we require to look at the S-way. And also, for the rafter also, permissible deflection is 125 mm. But as per analysis, we have taken only 72 mm. The reason is, sometimes what happens, if the excessive deflection is there, there is a chance of ponding over the roof also. That is the reason we have limited this. It is such a height, 55 meter. If there is a ponding, if there is a leakage, then the problem will be more. I mean, we cannot operate this kind of a structure, and we cannot maintain it also, because going up to the 55 meters and maintaining is also a big task. As I explained, these tie beams are quadrilateral lattices, all made up with Tata structural members. And all plates we have used Jindal. Rafter also we have made with Jindal sections, all the plates. So, and purlins and side runners, Z purlins. So during construction stage, this is a MSW pit, minus 5.5 meters below the ground level. This is a raft. So instead of putting a shuttering, they constructed wall itself like that. So because there they wanted to finish in no time. This is the ash pit during construction. This column, MSW pit column, up to 40 meters from the ground. Just imagine how much care they have to take to erect these, I mean, shuttering and all. It has become very difficult, but they had to do that because it is a MSW. Invariably, we require to go with a RCC. These are the base plates and bolts for various column sizes. Now you can see the human with respect to the column size what we have given. Mr. Mittal from the project engineer is standing tall, is 6 feet height, and the column is also 6 feet width, lengthwise. That's a 1200 by 1800 column. So 22 meters column during erection. At every 4.5 meters, we have taken a tie beam like this. So the erection became very easy as such. Not so easy, of course. So as we go up, that 55 meters column size also we have reduced to economize the structure. And this is the splicing connection. Therein you can see the photograph, how the splicing has been done. This is a back filter area erection photograph. This is a 55 meters column erection. So they have taken utmost care in erection of this 55 meters column. Not even a single day they complained that there is a problem in erection and all. They have absolutely done a marvelous job, I can say. Erection of 55 meters column with such a big crane operating and all aligned properly, everything. It's a big challenge, you know. And that too they have completed in 10 months. And this is the rafter erection. During sheeting work, this is the photograph. This is the other side of the view. Photographs have been taken from a drone. This is another photograph. This is a nearing completion. This is a total bird's eye view of the total layout now. Another bird's eye view. Yeah, this is a small video. This is a dump. So all the dump will be collected here. After that, it will be transported from the into the tipping hall. This is a tipping hall. So from the tipping hall, it will be dumped into the MSW pit. This is the boiler, and this is the other areas. This is another video. So this is the driveway. From here, the dump will be taken into the tipping hall. The chimney is 60 meters height. So height of the structure is 55 meters. So we have a great opportunity to work in this project because it's an environmental friendly project. So what we need to do, so each one of us think, so how we can give back to the Mother Earth. So what our effort is, so that the clean environment can be achieved, each one of us, and the government should also think it should be established in each and every city, so that all the waste will be converted into the energy, so that it will be helpful for the society. These are the projects we have done. That's a Trivium project Mr. Jagadish Babu was telling. This was the first project, Phoenix first project we did. So morning he was explaining it. We did for Phoenix 5 projects. That's a Trivium, IVY, residential project Halcyon, and Phoenix Premia we have done. And also we are into, this is a IVY project. So this is a BMR feed plant. We have done nearly 15-20 feed plants. And also we are into RCC buildings. So that's this building is a 27-storied building with a transfer slab. We have completed, presently we are doing 40-storied building in RCC. Thank you very much.